Looking down from the edge of space, you see a world of striking contrast, an intricate dance of chaos and order. There are cities lit by power plants and streetlights, vehicles weaving through networks of roads and patterns that seem both structured and frantic. Yet alongside this human order, nature asserts herself. Unpredictable weather systems swirling across continents, sometimes nourishing, sometimes devastating. The Earth, in this way, is a microcosm of the universe itself. Chaos and order entwined, confusing at times, but always, somehow, intelligible. Have you ever wondered why the universe seems so perfectly suited for life? Why gravity, light, and all the fundamental forces are exactly what they need to be for us to exist? That question leads us to something called the Anthropic Principle. It's a philosophical idea rooted in cosmology and physics, and it begins with this mind-bending observation. The universe has incredibly specific physical constants, so specific they allow life to exist. And not just any life, but intelligent observers like us. There are two main versions of the Anthropic Principle. Let's start with the first, the Weak Anthropic Principle, or WAP. This version says that the universe appears fine-tuned for life because if it weren't, we wouldn't be here to observe it. Philosophically, this is a tautology, a statement that is true by definition. It doesn't attempt to explain where the universe came from or why it exists. It simply points out the obvious. Our very presence as observers means the universe must have the kind of properties that allow us to exist. Take gravity, for example. To allow a universe capable of forming stars, galaxies, and ultimately life, the value of the gravitational constant, mathematically referred to as g, must fall within an incredibly narrow range. Even slight deviations would make life as we know it impossible. Physicists Martin Rees and others have offered striking estimates as to how precise this constant must be in order for the universe to exist. If the strength of gravity were different by just 1 part in 10 to the 36th power, the universe would be radically different. Let's break that down. If gravity were stronger by this absurdly minuscule amount, stars would burn hotter and faster, incapable of forming stable, long-lived stars like our sun. On the other hand, if gravity were weaker, matter wouldn't clump together. No stars, no galaxies, no you or I. The universe would be a cold, diffuse cloud of particles. To put the odds of 10 to the 35th power into perspective, consider this. There are an estimated 10 to the 24th power stars in the entire observable universe, which are far, far more than we can see in the nighttime sky. Closer to home, all the beaches on Earth contain roughly 10 to the 18th power individual grains of sand. Numbers like these, expressed as powers of 10, can feel abstract, so let's use a more tangible analogy. If you stack 10 to the 24 dollar bills, each 1 millimeter thick, the stack would extend beyond the nearest star, more than 100 light years away. But if you tried to stack 10 to the $35 bills, you would need billions of universes, each 100 billion light years wide, laid end to end just to contain the stack. Put another way, the odds of the gravitational constant being precisely what it needs to be for the universe to exist is equivalent to randomly selecting a single star out of 1 trillion universes the size of ours. We don't even have a word for the number of shorelines you need to search to find that 1 grain of sand. But this isn't even the most striking feature of our universe. There's a remarkable and still mysterious process by which organic compounds are forged in the stars, compounds that are the essential precursors to life. We have no known example of a living organism that wasn't built from organic compounds. These are required to form amino acids, nucleotides, sugars, lipids, and all the molecular structures that make life, and ultimately human intelligence, possible. The thing of it is, the process by which stars manufacture carbon atoms is remarkably odd and also very precise. This leads to one of the strangest stories in the universe, how carbon, the very backbone of life, is made inside of the stars. It all begins when a star runs out of hydrogen and starts fusing helium. Now, when 2 helium nuclei, known as alpha particles, collide, they briefly form beryllium-8. Here's a first oddity. Beryllium-8 is shockingly unstable. It lasts less than 1/trillionth of a second before breaking apart again. To create carbon out of it, nature must build on a foundation that instantly crumbles. Even so, in the heat of a star, molecules are moving at extremely high speeds. When you combine this with the density of molecules in a star, you end up with a tremendous amount of collisions. This means that, every once in a while, a third helium nucleus collides with that unstable beryllium before it decays. When that happens, all three combine to form carbon-12. This rare event is known as a triple alpha process, 3 helium nuclei colliding with perfect timing, producing the seed of life. The thing of it is, mathematically, it should be far too rare to produce the abundance of carbon that is needed for life to arise. There must be a joker in the deck, and there is. In 1954, physicist Fred Hoyle predicted that carbon-12 must have a very specific resonance, a kind of quantum sweet spot, that makes this reaction far more likely. It was an informed guess, nothing else made sense, but it was also spooky. How could all of life be dependent on such a striking coincidence buried in a footnote of physical law? Yet eventually, Hoyle was proven right. The resonance was demonstrated experimentally. Of this, Hoyle famously stated, "A common-sense interpretation of the facts suggests that a superintellect has monkeyed with physics, as well with chemistry and biology." The statement was controversial, not only because of science's secular orientation, but also because Fred Hoyle himself had long been an avowed atheist who firmly rejected religious explanations for the universe's existence. Yet confronted with another troubling question, the astonishingly early appearance of life on Earth, Hoyle proposed the idea of panspermia, the notion that life was delivered to Earth from space, perhaps via an asteroid. Why such a radical idea? Because life on Earth seems to have emerged almost immediately after conditions became suitable. Liquid water, essential for life, was present about 4 billion years ago, and evidence of microbial life dates to within just 200 million years of that. On a geological timescale, that's incredibly fast. It stretches credulity to think that, in such a short window, blind chemical process not only created increasingly complex organic compounds, but also stumbled upon a working genetic code, one capable of accurate replication and just the right amount of mutation. That delicate balance would eventually give rise to the vast diversity of life, including intelligent beings. To Hoyle, this timing seemed too perfect to be a fluke. Hence, his willingness to explore alternatives, even ones that sounded like science fiction. It also underscores his personal reluctance to express a simpler solution, that a collage of coincidences is far less compelling than purposeful intelligence. Ultimately for Hoyle, the carbon coincidence was a straw that broke the secularists' back. Hoyle would never become fond of organized religion, yet the evidences of nature gradually convinced him of the existence of a superintellect, even the intelligent design of the entire universe. To understand Hoyle a little bit better, you must understand the odds against carbon existing in the quantities that are needed for life to develop. The best estimate among researchers is the probability of these life-essential organic compounds assembling by pure chance is less than 1 in 10 to the 40,000. Staggering doesn't even begin to capture the magnitude of that number, especially when you consider that the total number of atoms in the observable universe is only about 10 in the 80th. Imagine this. Each atom in the universe represents an entire observable universe. Now imagine a universe filled with atoms the size of observable universes. Repeat that process billions of times. You're still nowhere near 10 to the 40,000. Or this. If 10 to the 80th power is like a grain of sand, then 10 to the 40,000 power is like a mountain range of sand so large it wouldn't fit in trillions of multiverses. Pick a single grain at random. It must be the exactly right one or life isn't possible. Get the only correct one or there is no life. Now consider the odds of the gravitational constant being precisely what it is, finely tuned to allow stars, planets, and life to exist. Not only must both improbable conditions occur, but they must exist simultaneously. The combined odds are smaller than the total number of physical or computational events that could have occurred in the entire history of the universe. The odds of these two things happening simultaneously is the same as finding one specific grain of sand in a universe of trillions of multiverses and then flipping a coin 40,000 times and getting heads every time all at once. The Goldilocks version of the universe doesn't end here, but those two examples are enough. You can't make the improbabilities work from a statistical standpoint without an endless supply of slightly different universes. In essence, the merger of weak anthropic principle to the multiverse combines the worst of both theories. The reasoning is circular, it prefers statistical juggling to physical explanation, and can be replaced by a much simpler theory. And with that, the secular explanation collapses under its own weight. It is a hypothesis that demands an enormous, entirely unobservable system, a metaphysical construct that stretches far beyond what science can test or verify. And it does all of this to avoid the more straightforward conclusion. The shocking amount of order in our universe is not caused by randomness, but purposefulness. The universe was designed to produce life, and there's nothing that chaos can do to stop it. The weak anthropic principle sidesteps these issues while the multiverse explains them away in an odd appeal. If everything is possible, then anything is possible. Though the multiverse explanation is ostensibly argued by secular materialists, it is wholly incompatible with the scientific method. It asserts that randomness has conspired with fixed laws to create intellect by conjuring up massive numbers. There is no other theory in science that works in this direction. The laws of nature represent order, and by them we can predict the result of theoretical events. In a weak anthropic multiverse, the source of all order is actually disorder, the creation of intelligence produced by the multiplication of chaos. In other words, if you give disorder enough opportunity, it will eventually deliver a planet full of humans. This is what happens when otherwise smart people are driven mad by their own intellect. But let's not be too dismissive. The weak anthropic principle has got this going for it. Though a tautology, which is of limited use in answering profound questions, it is also true. If we exist, then the universe must possess the precise conditions required for our existence. Our existence biases us to observe a universe that supports life. After all, we couldn't possibly observe a chaotic universe, one with no stars, no galaxies, no carbon, and no life, because in such a universe, there would be no observers. The logic is internally consistent. To the degree that we first accept that we indeed exist, we shouldn't be surprised to find a universe that supports our existence. The logic is internally consistent, if not circular. Why do we have such a precise universe? Because we must have such a precise universe to exist. Why do we exist? Because the universe is so precise. It's a perfectly uncontroversial bit of logic, restricting itself narrowly to only that which is obviously true. If we are a product of the universe, then the universe must be capable of producing us. Of course, this doesn't address a more compelling question. In the face of such extraordinary precision, isn't it reasonable to ask whether the universe was created with purposeful intent? And if the outcome of that precision is intelligent life, doesn't it follow that the intention behind the universe is itself intelligent? This is where materialists, who believe that all existence can be explained by matter, marry two logical theories into the bastard of the weak anthropic multiverse. So as to not build up too much of a straw man, let's begin with the basic idea of a multiverse. In our experience of this universe, we observe that natural laws tend to produce an abundance of outcomes. We have countless stars, countless planets, billions of humans, millions of species, thousands of black holes. Nearly everything in our universe exists in vast numbers, often with slight variations. This pattern of prolific variety forms a foundation for imagining a multiverse, a reality where even entire universes may exist in countless forms, each with different physical laws or constants. Proponents of the weak anthropic multiverse go beyond the basic idea of this multiverse. As the argument goes, given enough chances, it becomes statistically inevitable that a rare universe will emerge with the precise conditions needed for life. And since conscious observers can only arise in such a universe, they are destined to find themselves in one that appears extraordinarily fine-tuned. Let's use an analogy. Imagine a giant lottery machine with billions of balls. Each ball represents a different possible universe with different physical constants. Gravity, electromagnetism, particle masses, etc. Most balls contain universes where stars never form, atoms are unstable, or life is impossible. But a few, very few, are just right. They're the Goldilocks balls. Given the fact that we exist, we obviously find ourselves in one of those balls. At its core, the multiverse explanation for our finely tuned universe is simply the weak anthropic principle in disguise. Though popular in some scientific circles, it leans more towards metaphysics and science. One major issue is that it's unfalsifiable. Its claims cannot be tested or disproven. As philosopher of science Karl Popper famously put it, "It's not science if you can't prove it wrong." What's especially noteworthy is that the multiverse is often embraced by atheists, many of whom criticize religious belief for making similarly unfalsifiable claims about the existence of God. A second issue with the multiverse hypothesis is that it substitutes probability for explanation. This is a deeper problem than it might first appear, because the theory implicitly assumes that certain fundamental features, like the laws of physics, are consistent across all the universes. In other words, gravity is still gravity, just slightly different. Electromagnetism remains fundamentally the same, only tweaked. Nuclear forces, organic chemistry, quantum mechanics all persist with minor variations. But the hypothesis does not explain the origin of these laws. Instead, it treats them as self-evident, perhaps eternal, and inherently capable of generating limitless matter and energy. The specific constants that fine-tune the relationships between these forces are considered malleable, subject to random variation, and, given enough universes, are expected to eventually produce intelligent life. Yet this is not presented as surprising, purposeful, or meaningful. It simply must happen, and the randomness behind it is assumed to be fundamentally unintelligent, justified only by appeal to probability. But that is not an explanation. Probabilities cannot create anything. They can only describe the likelihood of outcomes within a system that already exists. To say it happened because anything will happen in an infinite system is to leave the system itself and its remarkable structure unexplained. This is anathema to the scientific process. In addition, the multiverse hypothesis invokes infinity in a way that is often careless or uncritical. The reason it must do this, as described earlier, is the inconceivable probabilities involved. The first issue is that infinity is a concept, not a concrete or rational mathematical quantity. While certain equations can point towards infinite outcomes, infinity itself is paradoxical and not directly observable. For example, if there are an infinite number of universes, then there are an infinite number of universes where you exist exactly as you do right now. In the same house, married to the same spouse, with the same children, driving the same car. But there are also infinite universes where you're slightly different. Your hair is blonde instead of brown, you're an inch taller, you're the President of the United States, or you're a serial killer, or you're both. In a truly infinite multiverse, every possibility not only occurs, it occurs an infinite number of times. That's not just bizarre, it's logically destabilizing. It leads to outcomes that are mathematically possible but philosophically irrational. We don't employ such explanations anywhere else in science. As either a philosophy or a metaphysic, it's odd and poorly developed. As science, it's illogical, which is exactly what infinity is to mathematics. The real test comes with Occam's razor. The scientific principle that the best explanation is the one that requires the fewest assumptions while still accounting for all of the observed complexity. In other words, the laws of our universe appear to be as simple and as efficient as possible, yet still capable of producing the extraordinary diversity we observe. In scientific terms, these laws are described as elegant. They show no signs of having been randomly cobbled together. Systems produced by chance tend to be messy and inefficient, features wholly absent in the laws of our universe. Take biological evolution, for example. Organisms often exhibit redundancies, vestigial structures, or inefficient processes, features that reflect the trial and error nature of random mutation and natural selection. These irregularities bear witness to the role of uncertainty in shaping life. But when we look at the genetic code itself, the story changes. It's not messy at all. The structure of DNA and the language of genetics perfectly fulfill Occam's razor. They are as simple and efficient as they can possibly be, while still giving rise to the staggering complexity of living organisms. Here lies the fundamental weakness of the weak anthropic multiverse. It is evident from our own universe that chance did not create the laws of nature. These laws are elegant, simple, and yet fully capable of producing the extraordinary order and intricacy required for biological life. Chance does play a role, but that role is in generating diversity, not in establishing the foundational laws themselves. Moreover, in the strange domain of quantum mechanics, chance behaves even more curiously. It often appears that certain outcomes don't become real, don't collapse into definitive states, until they are observed. In other words, probabilities in the universe don't point to intellect. Instead, they seem to depend on the presence of intellect or observation to take concrete form. The strong anthropic principle, or SAP, suggests something bolder. It also affirms that the universe must have properties that give rise to life. Some scientists and philosophers believe that constants like the speed of light, the strength of gravity, and the cosmological constant aren't just random. They may be selected in a way that makes life not just possible, but inevitable. The implication? Life isn't just a cosmic accident. Rather, it is the central feature, maybe even the purpose, of the universe. Critics complain that this crosses into metaphysics, but, of course, every attempted explanation of the origin of the universe falls into this same trap. Whether you see it as coincidence, inevitability, or something deeper, the Anthropic Principle invites us to ask the biggest question of all. Why are we here? And was the universe meant for us? Thanks for watching. If you'd like more videos on this topic, please hit the subscribe button. Let me know in the comments below whether you think the universe is special or just a stroke of cosmic luck. Until next time.